Okay, for this next problem, we're asked to find the centroid of this ellipse, half ellipse, and first we're asked to draw it. So first we'll start by drawing it. It's a useful skill if you're not given the exact equation for something. Okay, so to draw it, I know it's going to look like some sort of circular thing, but I'm going to try to draw the x and y intercepts so that I can see what it looks like. So x equals 0 is going to be the y-intercept. I'm going to have y squared over 9 is equal to 1, where y is equal to plus and minus 3. That's going to be this point here. This point means y is equal to minus 3, y is equal to 3. And then to find the x-intercept, I'm going to set y equals 0, and I have x squared over 4 is equal to 1, where x is equal to plus or minus 2, but we're on this part, x greater than or equal to 0, so x is equal to 2. These are only x-intercept. Okay, so we can draw this thing. We know it looks like an ellipse. It goes through these points, and it's going to be this, and we're interested in this region in here. Okay, so now that we have that, we want to find its centroid. So centroid is another way of saying center of mass, the coordinates of the center of mass. So this is going to be x bar, y bar, right? And again, we know this is my over mx over m. But similar to the last problem we did, we saw that we had m was equal to rho times area, mx was equal to rho times some integral of something, and y was equal to rho times some integral of something. And so it turns out that we don't need the mass. You saw it canceled out in the last problem. All we need is these integrals and this area, but we're given the area. We're given that the area is equal to, what is it, 3 pi? 3 pi. Similar to the last problem, we could do another trick, and we can look at, well, what should y center of mass be? So we can see in this region above the x-axis, there's as much mass as there is below the x-axis. Right? This area is as much, if I drew this right, as this area. So we see that y bar should equal 0, right? And you can think about this as if you had to balance this plate. You put your finger right here. Maybe it moves a little bit in this direction, but it's not going to be in this direction. Right? It's not going to be up here, because then the plate's going to fall this way. So you have to put your finger here to balance the plate. Okay, so we know that y bar is equal to 0, so mx has to be equal to 0 by symmetry. You can calculate it, and you'll find the same thing. Okay, so what we need to find, we know that mx equals 0, what we need is my. So for two curves, just random curves here, from A to B, this is their interior. The my is given by rho integral a to b x f of x minus g of x dx. Okay, so here that's a little bit tricky, right? We don't have something so obviously. I mean, we see that this is the top curve. We see this is the bottom curve. But how are we going to figure out what they are? So what that means, we're going to have to solve for y. If you see, if you look here, we have f of x. This is going to be y is equal to f of x. And well, it looks like it's only going to give us one y. Let's try to figure that out. Okay, we have that y squared over 9 is equal to 1 minus x squared over 4, or y squared is equal to 9, 1 minus x squared over 4, also true. Therefore, y is equal to plus and minus, don't forget the plus or minus, 3 times 1 minus x squared over 4 to the 1/2. Right? Okay, so what we're going to have to do here now. So what it turns out is that if you look at our picture up here, well, this one is going to be the plus square root. Now let's look at a picture up here. This is going to be our plus square root because y is greater than 0. This is going to be our minus square root because y is less than 0. So what we have is that f of x is equal to 3, 1 minus x squared over 4, 1/2. And g of x is equal to minus 3, 1 minus x squared over 4 to the 1/2. Okay, so now if we look back up at this formula, we don't need our row, right? We already decided we don't need that. So we have my. Well, a to b, our bounds are going to be from 0 to 2, right? That's the x-intercept. So 0 to 2, x, and then we have 3 times 1 minus x squared over 4 to the 1/2 minus negative 3, 1 minus x squared over 4 to the 1/2. Right? So if we put a little box here, we get that, dx. Now look, this negative sign just comes in, so we have two of them. So what we really have is that my is equal to 2 integral 0 to 2 times 3x square root of 1 minus x squared over 4. I'm going to write this as this, like this. Okay, so now we can bring out the 2 or the 3, and we just have this integral x 1 minus x squared over 4 to the 1/2 dx. And we see this is just a nice u substitution. U is equal to 1 minus x squared over 4. So then we're going to pick up our 2x dx. Du is equal to, well, it's minus 1 over 4 2x dx, or minus 1/2 x dx. So we're just going to look at this integral on its own. This integral x 1 minus x squared over 4. I'm going to drop the bounds for now. I'll plug them back in once I get to the end. This integral is just minus 2, right, if we're solving for x dx, minus 2 integral u du, oh, this is to the 1/2, u to the 1/2 du. Well, this is going to be minus 2 times u to 3/2 times 2/3, which is going to be minus 4 over 3 u to the 3/2, which if we plug back in for x, u is equal to 1 minus x squared over 4, and this is going to be to the 3/2. So we had my is equal to 6 becomes minus 4 over 3. That's 1 minus x squared over 4 to the 3 halves from 0 to 2, which is just going to be, well, we have minus 6 over 3 is 2, so minus 8. Well, if we plug in the first, if we plug in 2, we have 1 minus 4 over 4 to the 3 halves, so that's just 0, right? But then we have minus 1 minus 0 to the 3 halves, so just minus 1. So our answer is equal to 8. So that's my. Good. Now, that's my without the row term, right? So really what we find with if we're not given row, we're just given area, well, we already said that x bar, or we said that y bar was 0, so x bar is equal to my over mx over m. So my, we're just going to, we call this 8, and say m is 3 pi, because really you would have a row in here, right? Because this would give you mass, and then this would give you the actual my. But we got rid of the row because they cancel anyways. And this one's 0. So what you end up with is 8 over 3 pi and 0. And that's your final answer.